Yes, consider this biology question. A potometer with a leafy shoot weighed 18.9 gram initially and weighed 17.9 gram after 1 hour. From this, it follows that A, the shoot absorbed 1 gram of water per hour. B, 1 gram of water per hour evaporates from the potometer. C, the shoot lost 1 gram of water per hour. D, the potometer water receded at the rate of 1 gram per hour. E, the shoot was respiring and lost weight at the rate of 1 gram per hour. So let's consider each of these options. First of all, what is a potometer? So a potometer is a device used to measure the transpiration of a plant. So transpiration. So transpiration is the rate at which a plant loses water to the atmosphere. So, and this water loss comes from the leaf. It passes out through the stomata of the leaf. So, you know, generally plants absorb water from the roots. So it absorbs water, and the water will be transported through the xylem vessel to other parts of the plant, especially the leaf. So from the leaf, water will evaporate. So that process is known as transpiration. Now, through this transpiration, certain amount of mass, so certain mass of water will be lost. So that's why the entire mass of the entire mass of the plant may not remain the same after transpiration, as maybe after 1 hour. So there will be mass loss, and that's what happens here now. So when the plant is put inside the potometer, so there is a setup I will have. The whole setup weighs 18.9 grams. Now, after 1 hour, the setup, let me just make a small diagram of the potometer. So this is the plant inside the potometer. Now, the whole setup weighs 18.9 grams initially. Now, after 1 hour, it becomes 17.9. So if we subtract this from this, it means the whole setup has lost 1 gram. 1 gram of water. So that's lost. So this is true transpiration. Now, what is now happening here is that we want to choose which option best describe our answer. If you consider option A, this says the shoot absorb 1 gram of water per hour. So this is not even possible here. The shoot does not absorb because this is a tight environment. So it's not easy for the shoot to absorb water. And even if absorption is taking place without loss of water, then the mass of the whole system should not reduce from 18.9 to 17.9. It should either increase or remain the same. So option A is not correct. Let's see option B. 1 gram of water per hour evaporates from the potometer. Now, like I said before, I said the potometer is sealed. So there is no way the potometer itself can lose water to the surroundings. So in that regard, so there is no way, so this is not possible. The potometer cannot evaporate. So that means option B is wrong. Let's see option C. The shoot lost 1 gram of water per hour. This is the correct answer based on the explanation that I've made so far. So this is the correct answer. If you consider this, the potometer water receded at the rate of 1 gram per hour. So this is similar to what I explained in B. So it's not correct. Then this, the shoot was respiring and lost weight at the rate of 1 gram per hour. So respiration means taking in oxygen and giving out carbon dioxide. So even if this is happening, so the rate at which oxygen is taken and carbon dioxide is given up, the amount of weight loss in that case is negligible. So it cannot lead to a whole lot of 1 gram per hour. So this can also not be the answer. So therefore, option C is the correct answer. Thank you.